Welcome to the Algebra 2A review outline. We are going to outline the 4 units that we studied this trimester just to get an idea of what were the main points within each unit and what should I be looking to study. So the first question is, what is a function and how do we test it? In a function, that means that each input, that would be like each x, has exactly one output. So if 1 is x, it can only have one y that goes with it. And how do we test that? Well, on a graph, we would do the vertical line test. That means we put our pen or we draw vertical lines across the paper and see, does it cross the graph more than once at a time? If it does, that means it has more than one output and it's not a function. How do I interpret a linear function in context? Well, the first important part is, what does the equation look like? Mx plus b. M is the slope or the rate, and then b would be the starting point or the y-intercept. So we look for the rate and the start. So if it's in a word problem, you want to look for, okay, what is the starting point? That would be like the b, and what is the rate? How is it changing? Maybe it's a rate of pay. You get paid per hour. Something like that. And then the next one says, can I find and identify key features of a, well, the next thing we studied after lines was quadratics. So can we have an equation and find the key features, or can we look at a graph and identify them? And the standard form of the equation looks like this, where a, b, and c are just numbers, and we use those to find the vertex and the axis of symmetry. So the first thing I'm going to put on here for one of the key features is the vertex. So if I had a quadratic, and maybe it looks like this, the vertex is that little bottom point or the top if it's upside down. And to find the vertex, I first need the axis of symmetry. That's going to tell me my x-coordinate. So that's x equals negative b over 2a. And remember, the b comes from here, and the a comes from here. And that axis of symmetry is the line that divides it right down the middle. And then you can use that tells you the x-coordinate. You can use that to find the y-coordinate that matches with it. Then we also looked at the y-intercept. And that's, where does it cross the y-axis on the graph? And then, in addition to that, if you want to find it from the equation, it always ends up being that c value because we put in 0 for x. So whatever this is going to be 0, 0, and we'll just be left with whatever that number is. And then we spent a lot of time on finding the x-intercepts, which we also called roots, or zeros. And we had 3 different ways of finding these. One of them was by looking at the graph. So putting it into our calculator and then checking what it is. Where does it cross the x-axis? And we found that it was either twice, usually it was twice, sometimes it was only once, and in rare cases it was none at all. After graphing, we did factoring. When we factored, we actually did the little x method where we put the b and the c, and we found out which 2 numbers multiply to be c but add to be b. And those were our 2 factors, which could help us find the zeros, or the roots. And then our last method was the quadratic formula, which conveniently is right below it on our paper. So right here. So that would be a really good formula to make sure we write down. And then the next one says, how do I find, well, after we did the quadratic formula to find roots, we also used it to find the roots that we couldn't find, the imaginary or the complex roots. So how do I find complex roots? Those are the ones that have imaginary numbers, or they have I. So it has I in it. That means that the quadratic is floating up in the air, and it doesn't actually cross the x-axis, so it has imaginary roots. We only had one way to find these, and that was using the quadratic formula. We also practiced these, and we made sure that first you have to put it in standard form or equal to 0. So if you see a question where, x squared plus 2x equals 5, that's not set equal to 0, so you have to move everything to one side first. The next one says, how do I operate on, well, we were operating on complex or imaginary numbers. And what do they look like? Well, what do they look like? They look like a plus bi, where a and b are numbers. And how do we operate on them? Well, we know we can add, subtract, multiply. We did them by hand a little bit, but we also realized that we can do them in the calculator. So in our calculator, we found that the I was actually hidden a little bit. The pi key, when we hit it, that pops up, and we can hit the I, and that'll give us the I. So we can do anything with the complex numbers or imaginary by using the I in our calculator. And then the last part with the imaginary numbers was changing between that form, a plus bi, and radical. Radical means it has a root in it. So for that one, let's just make an example. How about if it was 5 minus 8i? So we want to know what radical expression would be equal to that. Well, if I want to go back to what it would have looked like, well, I know that I get an I when I have the square root of a negative because I can't take the square root of a negative number. I'm not going to change the 5 because there's no I on it. 5 minus, this is what I need to change because this has an I. So I know that it's an I, so it would be the square root of a negative number, and I just have to figure out, well, what number would I have taken the square root of to get 8? Well, 8 squared is 64. So the square root of negative 64 is 8i. And that was it for Unit 1. So those are all the main points from Unit 1. So make sure you go back and look at those. And let's go to Unit 2.